Welcome to my presentation for my project titled Machine Learning in Trading Systems Overcoming Predictability Challenges. So, trading performance in a machine learning setup can be improved in two ways. Either we improve the accuracy of prediction, or we can improve the methodology that translates our signals to actual trades. So prediction in of asset prices in financial markets can be a very challenging task because there are a large number of factors involved, and it's quite impossible to include all these factors in a modeling setup. So in this project, we would focus more on the second part where we use our model with poor accuracy and still try to be profitable. So the way the setup is designed is that we have our market data, which is daily data, which you can download from Yahoo Finance. It has open, close, low, high. So I'll create some transformations of these variables, technical variables such as uh, ATR, RSI, MACD, etc., and some moving average transformations. So this would be the dependent variables. Our target variable would be if the stock price goes up over the next day, or if it goes down over the next day. So, uh, so there are two approaches I'm going to take to try to deal with this low accuracy of the models. One is I've tried to trade many stocks simultaneously, which each have their own model. So we can. So here the idea is we can try to offset some of the uh, performance issues. Second is we would try to use some position sizing, which would try to allocate more capital towards models that are performing well during the period. So the modeling setup is going to be such that during the weekend we'll train a model using historical data on rolling basis, for example 60 days, and we use that model over the week, and when we again hit the weekend we rebuild a model. So and we're also going to take trade only a long only strategy. So when there is a prediction of up, we'll take a long position if the stock doesn't already exist in a book, and if it predicts down and if the stock exists in a book, we'll close the position. And because we're going to be trading many stocks simultaneously, we would come across situations where we have buy signal for multiple stocks. So when this happens, we'll try to allocate capital based on the expectancies of each of these models in the recent past. So the strategy development is going to be split into two parts. The first part is the development of the strategy, and the second part is the testing, where we do a final backtest. So for development, we are going to use only 5 stocks uh, from the Nifty 50 index. This was done for two reasons. One is we can reduce runtime. So when I'm trying out different models, it will run quickly. And the second reason being that I don't want to overfit. So since my backtest is going to have all 50 components, and my development is going to be on 5 stocks, this would control some of the bias involved. And one more difference would be that for development, I'm going to use only 3 years of data. For the final backtest, I'm going to use 4 years. Again, this period is probably not long enough, but this is mainly due to performance reasons. So the final backtest takes me about 1.5 hours for one run. So this is the reason why I've limited the time period used. So during the development process, I'll try out different models, and once we select a model, I'll try to tune the hyperparameters and have a final setup, which will then go on to be used during the backtest. And once we have our initial backtest, I'm also going to apply a series of realistic and adverse assumptions and try to see how our strategy performs. So I'm going to jump a bit here. So We can see here we have the accuracy. Accuracy is doing the backtest. So here we have the training accuracy, and here we have the auto sample accuracy. So first of all, we can see that there's about a 10% difference in the accuracy between the training and the auto sample. And also I'd like to bring to attention the ranges. So we have 48% to 52% for auto sample, and we have about 57% to 61% for the training. Now, so to contrast this, so remember this is for all 50 stocks of that we traded during the backtest. Here's an example of a single stock. So here we can see the variation. There's about a 20 percentage points in accuracy for the training, and for the testing we can again see there's about a 15 percentage points if I look at the slower moving average. If I look at the faster moving average, it's again something like 20 percentage points. So I haven't included all the plots for different stocks here because it would be too much for this presentation, but you'd have to believe me that uh, there was not any clear relationship between the different stocks and accuracy patterns. So hence we can see that we're kind of getting accuracy which is quite bounded between a narrow range of 4%. So during the development process, we found the logistic regression was the best model with regularization parameter C equal to 0.1. So it had good performance and low turnover. I think the reason logistic regression performed well is possibly it could capture trends as bias in the model. So if I have price data which goes on like this, logistic regression would try to capture this. So this means that it's probably going up in like 70% of days. So logistic regression would just apply a bias. Whereas if I try to use tree type models like random forest or something, it would try to fit into all these movements here. So this is my reasoning of why possibly logistic regression is performing well. And a note on performance. So we got an annualized return of 80% for the strategy. Here we have the have a passive buy and hold for the same 5 stocks used during development, and this is a Nifty 50 for comparison. Also, so since we said logistic regression best model, just illustration of the process which was used to select the model. So here's some metrics, some risk return profiles of each of the components during the development process. So we can see here we have 5 stocks. So first thing is that we can obviously see there's a huge difference in performance between random forest and logistic regression. Then I would like to point out the number of trades. So we can see that logistic regression made a much smaller number of trades during the period. So this would help us with transaction costs. Also looking at a profit to loss ratio for the trades, we can again see that here we have numbers like 1, and here we can see 4, 5, 2, 2. So this is a place where the logistic regression is performing better. Now looking at the win rate, we can see that the random forest is pretty consistent compared to the logistic regression. So this is a difference. So this is a place where the random forest has done better. But overall, when it comes to final performance, the logistic regression is still better. So our first set of results is with static Nifty 50. So what I mean by static is I look at this point, I see the components of the Nifty 50 index. I go back 4 years, I invest in these, I start investing in these, and I use this for my strategy. And similarly for passive, I just go back to this point in the past, buy a equally weighted, create an equally weighted portfolio, and just watch the performance. So obviously there is a survivorship bias here, because if I look at actual data, there have been 15 stocks that have moved out of the Nifty 50 during this 4-year period. But anyway, we'll just look at the performance here. So for passive, we have about 20% annualized return. Here we have 36%. So the active has done better. So both of these have the survivorship bias. Uh, for the index, this is probably a more realistic number. So we'll move on to applying few more assumptions to the backtest and see how our performance degrades. So before we move ahead, I'd like to illustrate where the profits are coming from for the active strategy. So we'll go back. So why do we have so much profits here? About 1.5 million in profits over 4 years. So let's look at a few examples. So this is for Infosys, the PNLs. This is for the passive strategy, and this is for the active strategy. So we can see that we made, at some point we made a large position and we made a lot of money, and which didn't happen in the passive. Similarly for JSW Steel, we have a good profit here. So these are the places where our active strategy is really made its profits. So there have been few positions where it made a huge amount of profits. Especially Tata Motors, you can see that it actually lost money over time in the passive portfolio, but we have managed to make quite a bit of profits on this. So this is because of the position sizing, where we are able to concentrate our positions on few stocks based on our predictions. There are also examples to the contrary. So here's the passive portfolio for Bajaj Finance. Passive has done well. We are not able to make much money here. So during real trading, so we have market open, market lows. In reality, prices will be something like this. So so far we have assumed that we would make entry at close. So our models were built assuming were built on close prices. So we assumed we would make our entries and exits at close. So now what we're going to do is we're going to make an assumption of entering at some intraday price. So I've created a variable which is the mid of high and low. So the reason I've done this is because in reality it's very difficult to actually get an execution at close, right? Because there's no guarantee of execution if you try to put in an order that late. So in reality, if you really want to try to get a price near close, you would try to enter the market maybe 1 hour before close. But since the best data I have is high and low, I just created a variable which is the mid of high and low. So on first look, it doesn't seem like this should be a big difference, should create a big effect, but it does. So we can see here now our active portfolio has dropped below our passive. I would also like to point out that this is somewhat an exaggerated scenario, because taking the mid of high and low wouldn't be is probably a lot worse than just trying to get an entry maybe sometime before close. So now we'll come to using a point in time Nifty. So this is so we had a survivorship bias before, so we're going to remove this bias now. So what I did is I collated all the changes in the index during this 4 years, and imagine the red lines to be the points of time where there was a change. So whenever I hit this point, I stop trading the stock that was moved out and start trading the stock that was moved in. And for the passive portfolio, when I hit this point, I just remove the the passive stock from my I removed the removed stock from my portfolio, added the new stock, rebalanced it, and moved on that way forward. So we can see the performance here. So after I apply this assumption, I see my active has performed better than the passive. The passive, in fact, dropped below the Nifty 50, which kind of makes some sense now, because the Nifty 50 has some different weighting compared to an equally weighted that we assumed. So obviously it wouldn't be same. So, but for this backtest, I just assumed entry at market lows so that we can take things a step at a time. So again, here there is one point which I'd like to talk about. So when there is an index change, index constituent change, there would be an announcement before it becomes effective. Here I've assumed that I would apply the changes during the effective date, but it is possible that you can rebalance a portfolio even during the announcement date. So looking at the performance here, so active is still our active portfolio is still done pretty well, annualized return. But we'll have to go forward and see what happens when you apply all our assumptions. So this is an example of realistic trading and somewhat stressed, I would say. So point in time index constituents, which I've already discussed. Intraday prices we have discussed, which is somewhat a stress scenario. I've also used transaction costs. So I've used this model from actual broker. So the costs are going to be 0.1% capped to a maximum of 20 rupees for each transaction. So I found a transaction cost to be about 80k. So when I'm trading about 1 million in capital, I get about 80k over 4 years. Also, the transaction cost is slightly exaggerated because the actual broker's pricing is that delivery is free. So if I do end up taking delivery, my transaction cost will end up slightly lower. But anyway, there are a lot of other costs involved in trading, even things like your equipment costs, etc., etc. So I just thought I'll leave it as it is. So here we can see that now our performance has dropped quite a bit for our active plus costs. So we have about 8.5% annualized return. The passive portfolio was 6.15%. The Nifty 50 has done the best here. But again, this is not something we could realistically get because there would also be costs involved in being exposed to the performance of the index. I would like to point out that this is an adverse scenario. So in reality, we would probably get some performances slightly better than this. But this is good to know that we are still able to perform adequately even after applying these adverse scenarios. So there are a lot of things that I could not do in this project. One thing was that I figured out soon that there was no need to stick to the index stocks. Sticking to index stocks was useful for benchmarking my results, but I think in reality it would be better to be a little more aggressive and probably just trade the top, let's say top 40 index constituents, or even consider the next 50, which are considered to be part of the Nifty 50 sometime in the future. So definitely there could be some work done on trying to go beyond sticking to the Nifty 50 index stocks. Also, one more thing I realized is doing the model selection, I just chose 5 stocks and base my model on that. But I think it would be better to have a large pool of stocks, do some repeated sampling, and then figure out your final model. And this would naturally control overfitting because I would see quite a big range of stocks and performance to kind of make a final decision. And this was kind of obvious. I did not at all focus on the input variables for uh, the model used in this project. Definitely, there is some work that could be done. We could try to find which variables are good, which variables are not providing any value, and try to improve our predictions of model to some extent. But we do know that we would not expect to improve it to make a massive gain on that. But this is definitely something we can look into. So we found that we used models with poor accuracy, with a mean accuracy of 50%, and we could still use it for trading. We also found that the accuracy patterns among stocks are not very much related to each other. So that is something that we can make use of during trading. Position sizing helped us a lot. So this is what was the source of our profits. We could concentrate our positions in some stocks where we felt bullish. And we also saw that we could degrade performance a lot by changing our assumptions. But overall, I would say it was pretty adequate performance. Obviously, we can build this further and try to improve it. And finally, I look forward to continuing development, and I hope I can actually use this for real trading at some point. So, thank you very much.